Hello, we are KAIST student taking MS310, Introduction to Quantum Chemistry, and we will explain about Fourier transform infrared spectroscopy called FTIR, and the photo behind the title is Real FTIR in KAIST color. The word FTIR means infrared spectroscopy using Fourier transform. Effort: infrared spectroscopy is well known as the analysis of infrared light interacting with a molecule. Then, Fourier transform is required to convert the raw data into actual spectrum. So it is one of spectroscopic techniques.
Now let's take a look about how the FTIR spectroscopy is done. FTIR spectrometer generally consists of source, interferometer, sample, and detector. First, the radiation is emitted from infrared source. When this radiation propagates through beam splitter, 50% of radiation is refracted toward the stationary mirror, and other 50% is transmitted toward the moving mirror. Each radiation is reflected by mirror and recombined. Recombined beam passes through sample, and some of radiation is absorbed by sample, and rest of them transmitted to detector. So when the beam finally comes to detector, we can see the infrared spectrum of sample, which represent the molecular absorption and transmission. The left picture is the raw data of FTIR spectroscopy. For the analysis, we need to convert x-axis for the wave number or wavelength. We can do this by using Fourier transformation. Fourier transformation is a mathematical technique that decomposes a function of time into the frequencies. You can see the relation between time function and frequency function. Now I will talk about how to interpret the data. Typically, observance bands are grouped within two types: group frequencies and fingerprint frequencies. Group frequencies are characteristic of small group of atoms or functional groups, such as methylene, hydroxide, and carbon monoxide. They are usually unique to a specific functional group, making them a reliable means of identifying functional groups in a molecule. Fingerprint frequencies are highly characteristic of the molecule as a whole. Typically, interpreting FTIR spectra starts at the high frequency and to identify the functional groups present. The fingerprint regions are then studied to positively identify the compound.
Application: using FTIR, we can get infrared spectrum of absorption or emission of material including solid, liquid, or gas. FTIR has applicated like this: checking organic compound to identify unknown compound, checking heterogeneity, research on hydrobond, nanoscale spectroscopy. For example, there is one of thermoplastic elastomer polyurethane shown left. Polyurethane has this structure repeatedly, focused both like this and this. I measured polyurethane FTIR in KAIST color. Check each wave number of peaks, then analysis using reference table. Therefore, compound and bond are shown. Advantage: and last, there are advantages of FTIR. As the last graph shown, FTIR collects the data over the wide spectral range, but it takes less time, so it's easy to visual repeatedly. Moving part is only one moving mirror. There is less wear and high reliability. In FTIR system, sample is so far from source. In general, radiation of infrared frequency emitted by sample does not go through interferometer, so it's not detected as a result, and it's better to analyze the graph. It's end of explaining FTIR. Thank you for watching video.